Are dependent systems overdetermined or underdetermined? Imagine you're solving a puzzle with many pieces, but some pieces are duplicates or can be combined. That's similar to what happens in dependent systems of equations. When you look at a set of equations, some might be just different ways of saying the same thing. This means not all equations add new information. In systems of equations, especially those involving nonlinear equations and functions, dependency occurs when one or more equations can be written as a combination of others. For example, if you have three equations but one is just twice another, that third equation doesn't give you anything new. It's like having a duplicate clue in a mystery. Now, when we talk about overdetermined systems, we mean there are more independent equations than unknowns. Usually, this makes solving tricky because the equations might conflict, leading to no solution unless they are consistent. On the other hand, underdetermined systems have fewer independent equations than unknowns. This often results in many solutions because there aren't enough constraints to pin down a single answer. Dependent systems sit somewhere in the middle. They can have more equations than unknowns, but if some equations are dependent, they don't all add new restrictions. So, even if it looks overdetermined at first, the system might behave like a smaller, more manageable system. It can be consistent and have solutions because the dependent equations don't increase the number of constraints. For example, if you start with three equations but find one is just a multiple of another, you effectively have only two independent equations. If you have two unknowns, this system could have a unique solution. But if you have three unknowns and only two independent equations, then you have an underdetermined system with infinitely many solutions. So, whether a dependent system is overdetermined or underdetermined depends on how many independent equations it really has compared to the number of unknowns. If the count of independent equations matches the number of unknowns, there's a good chance of a single solution. If fewer independent equations exist, then many solutions are possible. And if there are more independent equations than unknowns, the system might have no solutions unless all equations are consistent. Understanding dependency helps us see why some systems that look complicated can be simplified. Removing redundant equations makes it easier to find solutions or understand the system's nature. This idea is especially useful when working with nonlinear equations and functions, where dependencies can hide in complex relationships. So, in short, dependent systems are not strictly overdetermined or underdetermined. Their classification depends on how many independent equations they contain relative to the unknowns.